All right, so this question is number 13 on your assignment. Again, we are proving that the left side equals the right side. Okay, and so what we want to do is we want to manipulate somehow so that the two sides look the same. All right, so if we take a look at this first side over here, secant to the fourth theta minus tan to the fourth theta, that is a difference of squares. I know it's to the power of 4, but you can view this as a difference of squares where one square would be secant squared theta and the other one would be tan squared theta. And we actually do see over here that we have secant squared and tan squared remaining over here. So that might be a good thing to do, is to try and factor that difference of squares. So let's try that. Again, that's going to be secant squared theta plus tan squared theta. Again, we're using the square roots, right? And when it's a difference of squares, it's the same terms. It's the square roots of each term. One is plus and the other one is minus. Okay? And so again, we're working on this one side and we want to make it look like this if we can. So now that we've got this separated, can we start to look at the individual pieces and can we substitute any identities within the factors? So for example, let's see if we still have this up here. Textbook. Here we go. So we have some of these identities available. We have others as well, like double angle and sum and difference, but certainly we're going to kind of look at the Pythagorean identities, right? So if we just, let me just clip those and bring those into our work here now. So I'll just kind of put this underneath so we can take a look at it. So what you want to do is you want to take a look and say, okay, is there any way that we can start to use some of these identities, like secant squared, for example. I see secant squared here. It's 1 plus tan squared. Okay, so you could substitute that. We do have another tan squared, so we'd be able to combine some like terms within that factor. That's a good idea. You could do the same thing over here. So why don't we try that? I mean, I don't know if that's going to work or not. I mean, that. Yeah. Do you have another suggestion or question? Yeah. Okay, so you're looking at rearranging this. Okay, so secant squared theta minus tan squared theta can come from here, yeah? Is that what you're saying? So secant squared, yeah, secant squared theta, yeah, and then minus the 1 equals tan squared theta. Yes, that would totally work as well. You can use this. You can use that, so then, sorry. What did I write? Yes. Totally. And like I say, there's lots of different ways you could go. But that's true. That equals 1 as well. And so you could just change this into 1. Yeah, that totally works as well. And then you'd have 1 times this first one. Yep, that's totally fine. That's great. I'm going to continue on with how I started because some of you might have tried that as well. So I'm just going to keep going with that. So certainly your idea there of manipulating this identity actually is a really great way to go. Absolutely. So again, let's change this to 1 plus tan squared theta. No manipulation needed here, so that's kind of nice and handy. All right. And again, 1 plus tan squared theta minus tan squared theta. All right. So what do we have here? We have 1 plus 2 tan squared theta. Sorry, it's getting a bit messy. And this ends up to be just times 1. All right. So we aren't there quite yet, but 2 tan squared theta, 1 plus 2 tan squared theta, we might want to look to see if we have anything we can do there. So there are two, does this show up for any other identity? You might want to take a look at your textbook or your cue card if you're kind of jotting some of these down all in one spot here. 1 minus 2 tan squared theta, I don't know if that shows up. Anybody notice that? Let's see if I can get to 1 plus 2 tan squared theta. That's an identity. So let's see. No, I don't see 1 plus 2 tan squared theta. So you could go ahead and do, now that we're on this road, let's keep going with it. So you could change tan squared theta into sine squared over cos squared. Not sure if that would help, but this is going to be a little bit longer road than than needs to be. But if you get started on a road like this and you say, well, where do I go? We just keep trying different things. So let's see what happens. 1 plus, I'm going to keep going with this, 2 sine squared theta over cos squared theta. Now, will that help us at all? Well, what we could do is we could combine these two terms. Like, for example, this could be cos squared over here. Cos squared theta over cos squared theta. And then this would be cos squared theta plus 2 sine squared theta over cos squared theta. Are we seeing any identities pop out here? Well, we've got a sine squared and a cos squared. You add those up, that equals 1, but there's a 2 here, so that one doesn't work. But I wonder if we changed cos squared to 1 minus sine squared. I wonder what that would do. 1 minus sine squared theta. Well, that's getting a little somewhere. We could combine some like terms here now. So at this point, you may be thinking, you know what, I'm going to try something different, and maybe you want to go back to, to step 1 again or step 2 again and rearrange this. That's totally fine. You can do that because that's going to get things done a little bit quicker. But if you continue through, there should be a way, even though it's long and arduous. So again, I'm going to keep going with this and see what happens here. So this is 1, see, minus 1 plus 2. That's 1 plus sine squared theta over cos squared theta. And now that we have this, we are almost done, because you can separate these now. 1 over cos squared theta plus sine squared theta over cos squared theta. And 1 over cos squared is secant squared theta, and sine squared over cos squared is tan squared theta. And I believe that's what we were looking for, secant squared plus tan squared. All right, so that's a bit of a longer process there, but again, yeah, see how secant squared theta plus tan squared, secant squared plus tan squared. So if you get off on a path that looks dark and lonely, you can certainly start again, but if you just keep plugging away, you should find the light. All right.